So you should have already filled out this, right? The vision notes, kind of gone over, labeled the eye, got a basic idea of what each part of it does. I'm going to go through the different pieces of the eye in a little bit more detail, maybe give some examples to hopefully give you a little bit more understanding there. Okay, so still, again, just the stuff that you should have filled out already filled in on that. So what happens when you see color, right? Or when you see light, when anything's happening. So right now you are like zoning in, paying complete astute attention to my talking to you all. I'm sure, and you're not distracted by all the things around you in your home, which I'm sure that you are. What happens there, right? So you've got light from the computer screen coming in. When that light comes in and hits your eye, here's what happens. So it first goes to that cornea. That is that like outer, different, like kind of like domed area covering the front of the eye. The light travels through there. Right? And that cornea doesn't have like blood cells or anything, so it's completely clear. So that's like that outer layer of your eye. When it goes through there, it then enters through your pupil. Consider that like an adjustable hole that's going to allow light in or not. So if you want to like simulate that, put your hands on there with both eyes closed and just like a little bit at a time, widen it, widen it, widen it, and let more light in. That's what the pupil does. The iris is the colored part around it. That's when you think someone has like, you have blue eyes, you have brown eyes, you have gray eyes, you have whatever colored eyes. The iris is what they're referring to. The pupil is the black hole in the middle, the opening that we all have. The iris is very unique. You could literally eye scan, and every single person, like their fingerprint, has a completely unique iris. If you want to check something out with the pupil, if you want to do some experiments, because again, you don't have much else to do. Go to your bathroom or a closed off room with a mirror, turn the lights off, like get right up next to the mirror and either have someone else or you yourself turn the light back on, right? Stare right into the pupil, and you'll notice it go from like super broad, right? It's going to be very, very wide, and it's going to real quick go and completely close off. So what it's doing is like, again, this is either letting in light. When it's super dark or when it's black, your pupil is going to expand to the point where it's like, give me as much light as I can possibly get. But when it closes down, it's like, hey, I've got enough light. I don't want to let too much in because I wouldn't be able to see. I've got to be able to process the depth to some extent. So bright light, super bright, the iris is going to expand while the pupil gets smaller. But if it's super dim or it's dark, your iris is going to tighten a little bit and let your pupil expand. So what happens after that, right? Like your pupil's letting that light in. What's really catching and understanding what the kind of the beauty of our processing, our visual processing system is this retina. This is where a lot of the magic happens. So what the retina is doing is this is the kind of like back surface of the eye. Think of it like as catching all of this information. So it is receiving all of this information. Tons of neurons, right? If we're going through the transduction process, this is the second step, right? This first step of the lens, the iris, the cornea, those is receiving it, right? The R, and then we're going back to step two. This is the photoreceptors in the retina are going to be transforming it into neural impulse. So the photoreceptors within the retina is that light sensitive inner layer, right? Layer around the outside. It's receiving information, and it's doing that through two different things: rods and cones. So our rods and cones. Let me move this around a little bit. Ooh, I'm in the upper left now. So what our rods and cones are doing is that they have two different jobs, right? So rods, what they're going to do is allow for like broader vision, right? If you want to lock in on one thing, like really pick one thing on the screen and really focus, keep your eyes and focus locked on that, but allow your like attention to broaden. Notice you can't really read the other stuff. You can't see it. They all seem kind of blurry, and then stuff off like in the distance and behind, like you can't really tell what it is. Rods are allowing you to like see the stuff around you, recognize the things around you, see peripheral vision. And other than that, though, it's like it's just giving us like blacks, whites, and grays. So think of rods as peripheral vision, whereas cones, they're what's happening when we're locked in. right? If I am looking specifically at the word lens, right? If my eyes are like locked in on the mouse right now with lens, I'm looking at that. Like my cones are giving me the details. They're giving me the colors. They're helping me understand what's going on. Whereas the rods are more on the outside, and different animals have different kind of variations on this. So I think of like dogs, they have way more rods. I think of like hunting animals and their ability to, if they have more rods, that means they can like see what's going on. They can react more quickly to threats. They can see better in low light. I think about cats and dogs whenever it's like 2 in the morning. I walk through and get up and go to the bathroom and bump into everything, and Padfoot's like perfectly navigating the home, right? Because he has way more rods. He can see in much dimmer light. Cones, however, humans have an abundance of compared to most animals, so we get way more color detail. We can see more and focus more on things. Right. So when our rods and cones are transforming this, right, most of this happening within the fovea. That's this like kind of a space here at the back where most of the rods and cones are like focused, right? Especially the cones. The cones are all like locked in on the fovea, so they are like giving us the detail, whereas the peripherals, right, the rods are a little bit more on the outside. It's again transforming those into neural impulses, and then once that happens, it's going to work its way down this large optic nerve, which is then sending that message on. It's going to be delivering it back to where it needs to go. So that optic nerve sends the neural impulses from the eye to the brain. So we've gone through that whole process: cornea, pupil, lens, back towards the fovea for the cones, the rods, are out here in the blanking, in the retina, receiving all this information. It's in transforming it into neural impulses in the optic nerve, which is made up of these bipolar and ganglion cells, sending it back towards the brain. Right, sending it into the brain for this then to process where it needs to go to the thalamus and the occipital lobe and the visual cortex. So the blind spot, remember the activity we did where you like had the piece of paper and you had to like zoom in and out until you find your blind spot? All humans have this. It's this tiny little spot that it's basically a small sacrifice that our processing systems make so that we can speed things up. Right, you've got to have this little spot where we don't have cells so that we can have this. The book called it a high-speed connection of this bundling of ganglion cells to quickly send messages back to the brain. So what this looks like, right, what the process is, well, after we process the information, the brain is actually going to like, the eyes are weird and compared to many other kind of our sensations in that we have so much information coming into our eyes. And the thalamus, like most things, has both a left and a right portion. So the way that the thalamus works, though, isn't that like the left hemisphere thalamus receives everything from the right eyeball. It's actually the right parts of both eyes are going to, you see this here in the pink on the screen, right? Both of that comes to the right thalamus. Okay, so I know we're used to like left goes to right, right goes to left. But in this case, right sides of the eye all comes to the right thalamus, left sides of the eye and the receptors and those ganglion cells are going to send it to the left side of the thalamus. And then what's happening with that thalamus, again, the grand central station, it then sends it back to the visual cortex in the, think about it, which lobe? Occipital, right? Occipital lobe here in the back. And then we've got this kind of magic parallel processing thing going on. See, I'm going to jump over to that one. Yeah, so then I've got this parallel processing shindig going down. So once our occipital lobe receives it, it's sending information in both like two streams, both like dorsal or upper. This is the like the where, it's sending the information of like spatially what's going on. Right? It's the location, the movement, the location, the movement. It's like how is this changing, right? Compared to the temporal, right, more the kind of underneath, working its way around on the sides. This is going to give us more like the size. It's going to give us the color. It's going to give us texture, details, things like that. It's more what compared to the dorsal or upper level of where. wouldn't worry about that too much. Mostly just understand that this is what's going on in this prospect, this process of parallel processing. We mentioned this a lot, but basically the idea that our brain is doing a ton of stuff at one time. So when we see something, we're not just analyzing where is it moving. Right? If we were just analyzing movement, we would see like a gray blob flying across the screen. Right? When I move my hand across the screen, you notice a lot of things. You notice the like pale white skin that I've got coming across the screen. You also notice the way that my hand is moving. Notice the form that it has, 5 different fingers. You notice the depth of it compared to my face and the rest of my body. So you're noticing all of those things, and you're not thinking about it, but your brain's just doing all of these things at once. It's not processing one, it's parallel. All of these things are happening, and your brain does the work for you. It combines this into one story, and it tells you, boom, hand moves across the screen. So 2 different things happening at once, the where and the what, both in the parietal and the temporal lobe. Think a minute, again, do some review. Where are those located? Parietal, up top, temporal. These are both of the sides, of parietal, temporal. All right. So again, what's happening on that color when you have these different when we're receiving that information? Right. We said our rods and cones. Right, they're receiving information both in the retina and the fovea. Fovea mostly cones. The retina has both, primarily rods, receiving that information, and then our brain has to process the color. So how does that work, and how are people colorblind? Like, color's funky. So really it happens in 2 stages. 2 things you need to know. These are the 2 main theories they were debating for a while in kind of the world of psych, but all in all, now we kind of recognize that one happens and then the other. The first is the Young-Helmholtz trichromatic theory. This is the one that most people would probably recognize, is that we've got those 3, right? 3 different cone receptors. So we've got red, blue, and green. All of these different cones are receiving the wavelengths, they're receiving the information of the light, and then they're changing that. They're helping us understand what it is, right? For us to see it, right? To recognize what color things are, or what wavelength they are rejecting and sending into our eyes. But that doesn't work perfectly, right? It doesn't totally help us understand like how we see things beyond red, green, and blue, right? How it is that when you're looking at yellow, you're like, that's yellow. That's not a combination of red and green, right? Like we have a way more complex things in that. And what happens on these like after images when you stare at something and then it like changes colors. So, but then what psychologists ultimately got to was that this is what's typically happening, the Young-Helmholtz trichromatic theory. But then we work through that, the opponent process theory kicks in. So opponent process theory is that you've got those 3 things, red, green, and blue, but they've also got an opposite, right? Everything's got its opposite. And when our cones are working, right, when our cones are working to receive that information, it's tiring, right? They're receiving a lot of information when they stare at it for a really long time. They're essentially like blocking the reception of the other, right? So when you're looking at red, your green is being blocked, right? The green is simply refusing to fire, refusing to give you any information. And so the red gets tired. And so then if you go look at a white screen, right, if you go look at a white screen, then it will show the opposite, right? The red is tired, so it won't reject that. So let's, where'd that go, right? So if you're looking at this, right, say you're like, right, let's see, let's go back, right? So here, you're looking at these like different shades of blue, right? All these different shades of blue. If you stare at that for long enough, right? 20, 30 seconds. So while I'm talking, I'd say stare in this, look at this for a long time. The different shades of blue on there are in the opponent process theory are like they're exhausting your cones at this very moment. So you're staring, you're staring, you're staring, you're staring. And then when you remove the image, right, what you'll typically see is its opposite color, right? You probably saw like very warm images through here. You didn't see blue. It was the opposite. Was this is very cold and blue. When you flip this after staring at it for a while, it looks very warm and yellow or orange or red. It's the opposite, right? So your white is a combination. It's basically sending you every single color at one time, which means that your eyes are receiving all of this color and translating it, and the cones translate it into white. So now you're looking at blue, but when your eyes, your cones exhaust that blue, they get tired of looking at this blue. Now white which is sending us all colors at once, you get an after image because your cones are too tired to show you the blue, which means you get to see the opposite of it. Okay, so it was showing you blue. Now, instead of showing you all the colors at once, which translates to white in our processing centers, it's actually going to show you red, yellow, orange, the opposite of whatever it was seeing. Last thing we'll talk about for sensation and kind of the anatomy is our feature detectors. These are like details. Good. Again, like parallel processing, um, our brain is doing the understanding of both like the motion, the form, the depth, the color, all of these at once. It can't do the form without these feature detectors. So this goes beyond color and motion and things like that. This is the bottom up processing, like the backbone of bottom up processing. It's these very specialized neurons that receive information from just like a few ganglion cells. So the reason we're able to see so much so quickly is because we have like thousands of ganglion cells blasting messages, neural impulses back to the occipital lobe. But what the specialized neurons, these feature detectors, are doing is that they're like receiving from one. Right? Instead of receiving the depth of like where things are in space, of trying to understand quick motion or trying to understand like how many colors are in this bird, right? What they're receiving is what is the outside line, right? If we're looking at this hand, it's going to receive only like the outside images. What are the absolute colors or the absolute like edges of things, right? It's going to give us the form that's going on there. All right, so we will. Let me see anything else I wanted to go on. Yeah, we can talk color vision real quick. Yeah, so we'll go over all of this.